Alright, welcome everyone to our lesson today on applying exponent laws. So, with our lesson, all we're gonna do is exponent laws and a lot of it. Right? But this is a very satisfying chapter or satisfying lesson because you get a very massive equation, a very massive fraction, but all you're doing here is to cancel everything out to get something very simple and very small. Right? So, just a quick overview of all the exponent laws we've covered so far. Alright, so again, this only works if they're the same base. So if we multiply the same base and different exponents together, we would add exponents. If we divide, then we subtract the exponents. If we have the exponent of an exponent, we multiply them together, so it will become m plus n. Okay, next, if we have two numbers or two different bases under the same exponent, then the exponent will apply to both bases. So ab to the power of m is just a to the power of m times b to the power of m. And similarly, same logic applies for fraction or division. A to the power of m over b to the power of m. Right? And just to quickly visualize or prove this, let's just take 2, right? 2 to the power of 3 times 2 to the power of 2. And 2. All right? So this is 8 times 4, getting us 32. Or we can write that as 2 to the power of 3 plus 2, which is 2 to the power of 5, which is 32. 2 to the power of 3 divided by 2 to the power of 2. This is just 2 to the power of 3 minus 2, which is just 2 by itself. Right? So this is saying 8 divided by 4, getting us a 2. Okay? How about 2 to the power of 3 to the power of 2? Right? This is pretty much saying 8 squared, or 2 to the power of 3 times 2, which is 2 to the power of 6, getting us 64. Right? So then, this is pretty much saying 8 squared, and this is saying 8 divided by 2, or 4. Right? If we have AV times to the power of m, let's take 2 into 3. So we have 2 times 3 to the power of, let's say 2. Right? This is the same thing as 2 squared times 3 squared, which is 36. That is the same thing as saying, 6 to the squared. Right? So as you can see here, exponent laws work if we are working with the same base, and only if we're working with the same base. So with that being said, this is pretty much all this chapter is to it. All we're doing here is simplifying a very big fractions. So let's start small first. X cubed times y squared, x squared, and y to the power of negative 4. So what we can do is put everything of the same base together. Okay? Because we don't see any single operation, so we don't see multiplication, we don't see division, we don't see plus, we can just assume it's all multiplication. So in this case, we can rearrange all the bases together. So x cubed and x squared gets together, and we have y squared and y to the power of negative 4 together. Right, and from here, once again, we'll use our exponent laws. We knew from earlier that the same bases, right, when you multiply them, we're just adding exponents. So in this case, we have x to the power of 3 times x to the power of 2. All we're doing here is adding the exponents together, like that. And same thing with y. Because we are multiplying, we're adding exponents together. Right? Even though it's a negative exponent, because it's multiplication, we're still adding, not subtracting. Right? So 3 plus 2 gets us 5. 2 plus negative 4, same thing as 2 minus 4, gets us negative 2. Right? And yeah, that's pretty much all there is to it. So as you can see, it's pretty satisfying, right? We're going from this kind of ugly looking expression here, into something small like this. Okay, let's do some fractions now. So we have actual numbers by ourselves. We just have nice, clean, whole numbers. But because they're in their fraction or division, we still have to evaluate them. Right? So, very nicely though, all of the bases are all aligned. So all we have to do is to say, okay, so we have a 10 divided by 2 over here. Right? We have a 8 to the power of 5 over a to the power of 3. And we also have b to the power of 3 times b, or over b to the power of negative 3. Right? So we could do all of them individually. 10 divided by 2 gets us 5. Okay? A to the power of 5 over a to the power of 3. All we're doing here is saying a to the power of 5 minus 3. Right? And then with b here, similarly, we have 3 minus negative 3. This will get us 5 and a to the power of 2 and b to the power of 6. Right? So again, pretty satisfying, isn't it? We're going from a pretty big fraction into just something like, oh, it's just 5 times a squared times b to the power of 6. Right? But this is useful because let's say a is 2, b is 3. Right? So instead of doing 10 times, let's say 2 to the power 5 times 3 to the power 3 over 2 times 2 to the power 3 times 3 to the power negative 3. Right? So instead of using the original fraction like that, we can then instead do, oh, this is just 5 to the power of 2 squared times 3 to the power of 6. Right? This is just a lot easier to calculate. Okay, next one. So we split everything up into the relevant bases. So we have the whole numbers here. We have the a, so a to the power of negative 2 over a to the power of a regular 2, I guess. Right? And we have b to the power of 2 over 3 over b to the power of 1 over 3. Okay, so 4 over 2 gets us a 2. A to the power of negative 2 minus 2 and b to the power of 2 over 3 minus 1 over 3. This gets us 2 times a to the power of negative 4 and b to the power of 1 over 3. Okay, so this is technically correct, or not technically, this is correct. But as a general rule of thumb, or for convention's sake, we always want to make sure that there is no negative exponent in our answer. Right? So in this case, we have a to the power of negative 4. So to make sure that's not a negative, right, we remember that whenever we have a negative exponent from our last lesson, all we are doing is flipping it upside down. So which means that a to the power of 4 gets flipped into the denominator, right? That's a reciprocal. And yeah, that will be the correct answer. So again, whenever we get a negative exponent in our answer, that is technically not correct yet, right? It's still the same thing, but for convention, we always want to make sure all the exponents are positive. And to make a negative exponent positive, we would just flip this into reciprocal into the denominator, right? But you also have to be careful here. We are only flipping the a here, right? Only a is to the power of negative 4, not the 2, not the b, which means that only the a gets flipped into the denominator, but the other 2 remains in the numerator. Okay? So now for the last one, we have everything to the power of 1 over 2. Yeah, but generally, we usually do the powers last, right? Just so we have smaller numbers to work with inside the bracket. So we have 100 over 25, we got the whole numbers. We got the a's, right? And we also have the b's, right? There's no b at the numerator place, so we could just have it as a 1. So b to the power 1 over 2. So all of that to the power of another 1 over 2. Okay, so 100 divided by 24, we have a 4. A to the power of 1 minus a 5. And then we have b to the power of negative 1 over 2. Right? And when we get to the b to the power of negative 1 over 2, we notice something here. We also have a negative exponent here. But this negative exponent is also in the denominator. So when we get rid of this negative sign, we just end up flipping it back up again. Right? So 1 over b to the power of negative 1 over 2 is just positive, or b to the power of positive 1 over 2. Right? So similar to how we flipped the negative a to the negative 4 to 1 over a to the 4, we are flipping b to the negative 1 over 2, being in the denominator, we are flipping it to the numerator. Okay, so we have all of that to the power of 1 over 2 again. And now we find the exponent for the a, which is negative 4. Right? We will quickly convert that, or we'll flip it to the bottom of the fraction, right? Because we don't want negative exponents. We get that, okay? Right, so now we have to get rid of this exponent out of everything. We have to get rid of it somehow. So what we can do is multiply everything to the power of, or not multiply, exponentiate. I don't know if that's a word. But exponentiate everything to the power of 1 over 2. we have a to the power 4 times 1 over 2, right? So all we're doing here is spreading this exponent to everything inside the bracket. Okay, so now what do we have here? 4 to the power of 1 over 2. This is the same thing as the square root of 4, right? Which is just 2, okay? 1 over 2 times 1 over 2 gets us b to the power of 1 over 4. 4 times 1 over 2 gets us 2, so it's a squared. Okay, well, there we go. Right, so those are some examples that we can use the exponent laws for. So with that being said, this is the fun part. This is gonna be a lot of big practices here. Right, so pause the video here and try them out yourself. But be careful here. Make sure that all the exponents are positive, right? If it's a negative exponent, convert it by flipping it upside down. The numerator to denominator, denominator to numerator. Right, so have at it. Okay, hope that was enough time for y'all to try those questions out. Let's go over them now. So the first one, we have the exponent of everything, right? So we have 4 to the power of negative 1 over 3 times n to the power of 2 times negative 3 times n to the power of 3 times negative 3. Okay? 4 to the power of negative 3 is 1 over 4 to the power of 3. And we multiply that by the m to the power of negative 6 times n to the power of negative 9. So we have to calculate 4 to the power of 3 and get rid of the negative signs of the m and n exponents. When we do that, we just flip it upside down. So 4 to the power of 3 is 64. We're going to extend the fraction here. M to the power of negative 6 is just 1 over m to the 6. So that goes to the denominator, and same as the n, to get us this fraction right here. Okay, so next problem now. Let's figure out this numerator first, right? Let's get rid of the exponent inside first. So we have c to the power of 3 times negative 1 times d to the power of negative 1 over c squared over d, all of that to the power of negative 2. So all we have left is c to the power of positive 3, d to the negative 1, and then c squared d. And from here, we do use our fractions exponent law, right? We get c cubed over c to the power of 2 times d to the power of 1 over d to negative 2. So we have c to the power of 3 minus 2, and then d to the power of negative 1 minus 1. Hold that to negative 2. This gets us c to the power of 1 and d to the power of negative 2. All that to the power of negative 2. Take everything to the power of negative 2 here to get c to the power of negative 2 and d to the power of negative 2 times negative 2. So c to the power of negative 2 times d to the power of positive 4. Okay, lastly, this guess is correct, but we do not like this negative 2 here. We will flip, or we get rid of the negative exponent by flipping it. So we have d to the power of 4 over c to the power of 2. Voila, there we go. Another daunting looking big fraction just reduced to just d over 4, or d to the power of 4 over c squared. Okay, next one. We got the whole number, so negative 9 divided by 3 times 8 to the power of negative 4 over 8 squared times b to the power of 3 over 4 over b to the power of 1 over 4. We got negative 9 divided by 3, which is just 3, or negative 3. We have a to the power of negative 4 minus 2. And then b to the power of 3 over 4 minus 1 over 4. Alright, that gets us negative 3 times a to the power of negative 6. And b to the power of 2 over 4, or 1 over 2. We get rid of the negative exponent. So a to the power of negative 6 is just 1 over a to the power of 6. Just like that. Okay, last one. Damn, I'm tired. This is a lot of talking here. Right off the bat, we want to simplify as much as possible before we bring in the exponent. But we have a b, and a c. All the bases are different. So we just skip straight to the exponent step. We have negative 6 over 4 times to the power of 1 over 3. C to the power of 6 times 1 over 3. A to the power of 9 times 1 over 3. B to the power of negative 1 over 2 times 1 over 3. Okay, that's a lot. Negative 64 to the power of 1 over 3 is the same thing as cube root of 64, or negative 64. C to the power 6 times 1 over 3, this is just 2. 9 times 1 over 3 is 3. And then 1/2 times a third is negative 1/6. The cube root of negative 64 is negative 4 right here. We have to get rid of this negative sign somehow. So we flip this b, so we go from the denominator to the numerator. So we have b to the power of 1 over 6, positive, and then c squared. And then we have a to the power of a third. And that's it. Right? So I keep saying this, but this really is pretty satisfying, right? We have all those big, ugly exponents, all those spaces, all that kind of stuff. But at the end, we can make something really simple like this, right? From this monstrosity right here. So with that being said, keep practicing and stay hydrated.